Hello guys, in today's video we will learn about functions, mappings, relations and some of function types and other things related to functions. So let's start. In first topic we shall firstly discuss about mappings or relations and then functions. What are mappings? So mappings or relation is something same. So a relation is made up of two sets and a rule that relates elements from the first set, the input set, to the elements of second set, the output set. Means it's a combination of two sets that one is called input set and other is output set, where they are related with some rule or maybe some operation, some time mean operations. The set of all permissible inputs is called the domain of the mapping, and the set of the corresponding outputs is called the range of the mapping. Okay, for example, suppose we have the input set 1 2 3 4 5. This set represents the domain of the relation. And then if we take the set is related to output set b is equal to -1 1 3 5 7 by the rule double and subtract 3. So what's the rule and what's the equation becoming? 2x minus 3 or 2a minus 3, there is variable a. So if we take 1, the answer will be -1. If you take 2, the answer will be -1. If you take 3, the answer is 3. If you take 4, then answer is 5. And if you take 5, the answer is 7. So this set A is domain and set B is range. What is domain? Domain is the set of inputs and range is the set of outputs. Here the rule is applying is double and subtract 3, means the domain where which we input is shall be doubled, and then the answer that comes is subtracted by 3, and so the result is the range which is called output, set of outputs. So that's it in that in front of us. Okay, now we discuss about types of mappings. So number one to one. There are four types. Number one is for 1 to 1. In a 1 to 1 relation, each element in the domain is mapped onto exactly one element in the range. Means if we, in other words, the definition is every input have its unique and distinct output. Means if we take a for suppose if we have an element in domain 1, so it have only one output -1. Or if you take any element in set B or range is suppose -1, so it have only one input 1. And if you take 0, it have one only 2. And if we take 3, it have one only output is 1. And the other type is many to one. In a many to one relation, two or more elements in the domain can be mapped onto the same element in the range. For example, means two or more elements, or one or two or more elements in the domain can be mapped onto the same element in set B or set of range. For instance, if we take this example, -1 and 1 have an similar output 1. And if we take -2 and 2, they have output same 4. And if we take -3 and 3, they have same output 9. Take another example, one to many. In a one to many relation, each element in the domain can be mapped onto two or more elements in the range. For example, if we take this example, one have -3 output, and one have 1 also. And if you take 4 have -2, and 4 have 2. And if you take 9, it have -3 and 3 also. And let's talk about last type, that is many to many. In a many to many relation, more than one element in the domain can be mapped onto more than one element in the range. For example, one that is its example very illustrated or very complex. So that's example that here is, that means that every domain is plotted on horizontal axis and every range is plotted on vertical axis. So it's an illustration of functions and not functions that are the relations. Here it's a function, it is a one-to-one function, and here we saw it's a, here we see that it's a one many to one function. And there is a problem that C have not have nothing output, so it not be a function. And here is that it A have two outputs, so it becomes one to many function, when one to many relations, so that we know that one to many is not a function. Okay, vertical line test. What is vertical line test? A vertical line test is that we can find out whether a relation is a function or not. A graph represents a function if it is impossible to draw a vertical line that intersect the graph more than once. Means if a graph have two intercepts that we draw a vertical line at any point in a graph, if it intersects the curve or a line or a graph two times, so that it will be no it will be not a function. And if it is like one time, so that it will be a function. Okay, there are some examples of functions and their relations such are not functions. There it is a function, it is a function because it has a one intersection, it vertical, and it have two and it have two, so that we, here is a point that circle is not a function, circle is a relation. Okay, here is also an illustration example so that you can easily understand. Horizontal line test. Horizontal line test, if every horizontal line intersecting the graph of the function does so exactly once, then the function is one to one. Or if any horizontal line intersecting the graph of the function does so more than once, then the function isn't one to one. Means if a function intersects, if a horizontal line that is drawn at any point or at any region in a function in a graph, if it intersects a function two times or two or more times, so that it is not a function. If it intersects one time, so it will be a one to one function. It is the difference that we can differentiate between one to one or that functions that are not one to one function. So it's a way that we test how that the function is horizontal line test. Okay, function notation. You usually use the letter F to represent a function, but other letters such as G and H can also be used. The letter X is normally used to represent elements of the domain input value. Since we can choose the value of X, it is called an independent variable. If we have the function is square and add 5, this can be written as f of X is equal to X square plus 5. We can also use mapping notations, so that f of x x square plus 1, x square plus 5. Okay. If we choose x to be minus 3, say we can write f of minus 3 is equal to minus 3 square plus 5 is equal to 14. We said that 14 is the image of minus 3 under the function f, and we also said that 14 is the output of minus 3. Minus 3 is an input which is lying in the domain, and 14 is lying in the range. So the letter y is normally used to represent elements of the range, so y equals to f of x. Y is simply written in the place of f of x. Since the value of y is determined in the function acting on x, it is called a dependent value, because y is the set of range, and range are a set of outputs, and then outputs depends upon input that we does that we, if we don't have any output in any input, so that's we don't have any output. So it is clearly understood that y is the function, y is a dependent variable which depends on x, where that set of range depends upon set of range depend upon set of domains. Since the domain of function f of x, x square plus 5, has not been given, we assume that x belongs to set of real numbers. What is the range of this function? F of x cannot be less than 5, so that range is greater than and equals to 5. Remember, the domain of a function is set of values to which the function can be applied, and the range of a function is the set of all possible output values. Okay. A function is only fully defined if we are given both the rule that defines the function. For example, f of x is equals to x minus 4. The domain of the function, for example, the set 1 2 3 4, given the value of x is equal to x minus 4 and the value 1 2 3 4, we can find the range. Okay, So with that we have given a function x is x minus 4, and we have given the set of domain. So then we easily find out the set of range. Okay, the domain and the range of a function. It is more common for a function to be defined over a continuous interval rather than a set of discrete values. For example, the function f of x is equal to 4x minus 7 is defined over the function minus 2 less than equals to x less than 5. Find the range of this function. Since this is a linear function, substitute the smallest and largest values of x. So it is a clear understanding between domain and range, and we are differentiating between range and domain, and just go through the concept of domain and range of function. So now here's another topic: even on odd function. Even functions. What are even function? Even function. So for an even function, for every point x comma y on the graph, the point minus x comma y is also on the graph. So what does it means? If we have a function that is minus x comma y, it lie, and if we replace the values of x by minus x, it also lies on the graph. So even function have y-axis symmetry, that y-axis acts as a mirror line or axis of symmetry, that if we forget x-axis, the function uh, and its minus x value function have an symmetry and a mirror. Y-axis acting like a mirror, you can easily see that. And what is odd function? Odd function have origin symmetry. So for an odd function, for every point x comma y on the graph, the point minus x comma minus y is also on the graph. So if we substitute x by minus x and y by minus y, so that the point which is output, which is a result of that substituting, it also lies on the graph. So what we conclude, that odd functions have origin symmetry. And see next one, x symmetry. Let us see this topic. So when we discussed about equations, a function is even if f of minus x is equal to f of x for every number x in the domain. So if we this this talk is this sentence is also we discussed in previous slides. So in equation case, if we substitute that, suppose we have an example, 5x is x power 4 minus 2x square plus 1. If we substitute x by minus x, so the result would be also a function that is the previous function, that is the parent function. So this will call a even function, that we see if we substitute minus x and minus x, so the nothing would change in the function, so that the function is even. If we check this function, if we put minus x, then we see that the answer is not, answer is changed, and the parent function is not in the result. So this is not a even function. So if we discuss about odd function, if f of minus x is equal to minus f of x for every number x in the domain, so that will be a odd function. In this example, this is not a odd function, it is a even function, which we previously discussed, that if we put minus x, it will don't give this out relation, that minus f of x, if we take common, so the parent function will retain, so that will function, it's called odd function. Okay, some functions are neither even neither odd, so that they don't obey the rule of even odd function, so that's why they are called neither even neither odd. Okay, translations, it is an important topic and interesting also, that we have an, suppose we have an function f of x is equals to x square. So this graph is of this function. A function transformation takes whatever is the basic function f of x and the transforms, and then transform it or translate it, which is a fancy way of saying that you change the formula a bit and thereby move the graph around. For instance, the graph for y is equals to x square plus 3. looks like this. This parabola is 3 units higher than the basic quadratic graph f of x is equals to x square, especially x square plus 3 is function f of x plus 3. We add as 3 outside the basic squaring function f of x is equal to x square, and thereby went from the basic quadratic x square to the transform function x square plus 3. What does this mean? If we add in the function outside, means x square plus 3, that is, so it will transform to move upwards. The base function move upwards 3 by 3 units, so that is called moving up and down translations. That means if we add in the plus in the function, that something bit like 3 or any number, the function will transformed vertically upward. And for in and next case we may discuss about moving downward. So also this is always true to move a function up and you add outside the function f of x plus b. His f of x move upward b units. Moving the function down works the same way, but by adding a negative number, or which is the same thing subtracting a positive number. F of x minus b is function move down b units. That simply means if we add or subtract, add a value in the function, so the function is moved up, or if we subtract the value, the function is moved down. Let's see an example. We have to move the original function downward by 2 units. To make this happen, the new function is going to be the old one, but with a minus 2 tacked onto the end. G of x, and there we have another example. G of x is equals to 4x minus 3, and g of x minus 2 will become 4x minus 5. The function is moved down by 3 units, by sorry 2 units, moving left and right. Now we discuss about the horizontal shift. Let's begin again with this function y f of x equals to x square. We can also move function and their associated graph to left and to the right. For instance, y is equals to x square, x plus 3 whole square looks like this, that we add up in the x value, not in a whole function. In this graph, function has been moved over 3 units to the left, that is, function shifted 3 units to the left. This is the illustration of what happened. This is always true to shift a function left and inside the function's argument. F of x plus b gives function shifted b units to the left. Shifting to the right works the same way. F of x minus b is f of x shifted b units to the right. It is opposite to the rule that we have moving up and down, that we add so the function is moved up, or and we subtract the function is moved down. But in this case it is opposite, that we add so the function is moved left side, and if we subtract, the function is moved right side. Let's see also an example, that we have a function s of t is equal to 2t plus 4, and if we subtract inside the t minus 1, the function is transformed to the right side by 1 unit, and we have a new function 2t plus 2. To sum up, the rules for the function translations are: to move a graph upward, add to the function, and to move a graph downward, we subtract in the function. And if we move the function rightward, we want to move the function rightward, subtract from the argument of the x, that is f of x minus 4. If the function is f of x, then f of x minus 4 is translated to right side of the function of the graph. To move a graph to the left side, we add in the argument of the function, that is f of x plus 5, as the graph is moved leftward by 5 units. So that's all in this video. I hope that you enjoy and learn something better from my this video, and I hope you like this video. Please like and subscribe my channel, and please share this video. Thanks a lot. Thanks. Bye. See you in next video.